Welcome everyone. It's great to see such a big crowd here this afternoon. I've been told we've got the biggest crowd of the day, so thank you very much for that. My name is Andrew Booker and I'm the Earthquake Recovery Manager for Housing New Zealand for Canterbury. My team is responsible for getting all our properties repaired and for building all our new houses in Canterbury. I'd like to introduce you to Malcolm Jones, who's on the far right, who's a member of my team and is leading the work we are doing on the TC2 and TC3 foundation repair trials. Next to him is Gordon Ashby from Tonkin and Taylor. Gordon is a geotechnical engineer and he will be doing most of the talking this afternoon. Housing New Zealand is the same as everybody else in Canterbury whose properties were damaged in the earthquakes. We have over 3,000 properties on TC2 land and approximately 1,000 on TC3. This has meant we needed to find the most cost-effective and sensible way of repairing our houses with foundation damage. The work we are doing is quite specific. It only relates to our houses that have concrete ring and concrete floor foundations and that are on TC2 and TC3 land. We realised that when we started this project that the results would be beneficial to everyone in Canterbury and to those other property owners. So it's not, and that's why we filmed some of the work that we've done so far, and the geotech and structural engineers on our website. You can look on there for some videos that we've been taking recently. I hope you find the presentation informative, and when Gordon is finished, he and I and Malcolm will be able to take any questions. Thanks. Gordon.
Good afternoon, folks. Just an overview on this slide is the subjects that we'll be covering this afternoon, moving from an introduction into an overview of the repair pilot program, and then Gordon will take over and talk about the background on the geotechnical side, a bit more geotechnical information and structure, and then I'll come back and talk a wee bit more about the construction process to date. So this slide gives you an overview of the repair program that we have instigated. Obviously you're aware recently that we've settled our insurance. However, during last year we did, with the insurance, prepare and repair a number of homes. And those were specifically selected as minor damage, interior redex. However, as they were progressing, we then were looking at another tranche of work. And as we moved forward, searching for those properties, would it be appropriate, we found that we discovered a number of floor issues in the TC2, TC3 zone. Some of those properties have sunk in quite nicely, as you'd be well aware. Most of the properties were Type 2 foundations, concrete perimeter edge beam piled foundations. The perimeter beams that we looked at in our trial had a number of cracks which could be easily repaired. However, a number of questions were raised. Before we could fix these and repair these homes, how do you lift the foundation? When you lift, do you have to remove the bricks? If you do manage to lift the foundations up, what do you do with the gap that's created underneath the foundations? Also, while you're there, do you have to do anything to the land? When do you do this, will you cause other damage inside my home? So we raised a number of questions. So during this time period, we had a discussion with Southern Response, who we discovered were asking the same questions, and had a number of similar properties in the TC2 and TC3 lands. So we also talked to MBIE and brands who were keen to be involved in a group. So we formed this group for a trial and invited 3 geotechnical engineering companies, 2 structural engineering companies, MBIE, brands, Sarah, City Council and Waimakere District Council. We proceeded to select 20 properties over a range of suburbs, and we have 8 suburbs there. Now I'll come back and talk at the end of the seminar about where we're up to in this trials. In the meantime, I'll hand back over to Gordon for more of a technical analysis.
Thanks, Malcolm. Hi, everyone. Hope you've had a good afternoon. Can you guys hear me down the back? Speak up if you can't. Excellent. As Malcolm explained a bit about the foundation repair pilot program and selecting some of the sites where this work would be carried out, this just shows you a brief overview of obviously Christchurch City, and the green dots give you an idea of where some of those properties were or are, where the trial is going on. So what I was going to do was to just kind of provide a little bit of background, a little bit more detail about what we're doing from a geotechnical and structural perspective with the foundation repair pilot program, and then Malcolm will come back and give a few more details of the types of things that are being trialled. So most people don't really need a reminder, but just to bring us all to the same point, just a very quick overview of the events over the past couple of years or so, with obviously the Darfield earthquake and aftershocks, progressing through to the February event, coming through to the June one, and then the December aftershock as well, as we see the progression from west to east of the main sort of seismic activity, and most of it centred on the eastern part of Christchurch City. Just another quick view, I suppose, of the earthquake seismic activity over that period of time, and we can see we're probably all familiar now with the drop-off in seismic activity over time, so we're coming into a more settled time as far as earthquake activity goes. These next couple of slides just give you a bit of an indication of the relative magnitude of the acceleration that was generated by these seismic events. This is the September one. The vertical arrow shows you the vertical acceleration component, and obviously the blue one is the horizontal component. And if you just compare this slide perhaps, which is the September event, obviously with the February one, where you can see there's a heck of a lot more power in the loadings that were imposed on buildings, significantly more in the February one than September. And then through to the June aftershock, again we can see that as the eastern parts of the city got quite a bit more seismic loading. This is a view of the city. The colours represent the technical categories, and hopefully you can see them. The black dots are Housing New Zealand's properties right across the city. You can see they're quite well spread. Well, there's a representation in all of the technical categories of Housing New Zealand properties, including red zone right through to TC1. These next few slides show again the properties for Housing New Zealand, which are shown in black dots, and the colours represent the categories of land damage as observed by geologists and geotechnical engineers and engineering geologists that went out and made observations post the February event. And again we can see that there is quite a wide spread of the damage categories within the city and where Housing New Zealand's houses are located. And this is just working across the city. Again, we can see the red is essentially where all the lateral spread occurred around the Avon River and other areas similar. And then you've got major areas of liquefaction through to no liquefaction or minor areas. This is in the southern part, again going from west to east. And again, it's just giving you a bit of a flavour, I guess, that the Housing New Zealand properties are spread right across the city. They cover all of the TC, technical categories, and they span essentially from no damage right through to the most heavily damaged of the residential properties. So, as I say, that was a bit of background. I'll now talk a little bit more about the geotechnical aspects of particularly the foundation repair pilot program. I guess you might sort of ask, well, what do we need to know? Well, from a geotechnical perspective, it really boils down to kind of one fundamental question. What's the ground like? And then the second part of that question is, how does that then influence what happens to the buildings that are situated on the ground? So one of the key things that we need to find out before we do too much significant repair or rebuild work is, what is the ground like? What's it like beneath the ground surface? So we need to know sort of things, well, have we got conditions that in a seismic event we're going to end up with a lot of liquefaction? And generally speaking, there's quite a close correlation between the degree of sand material that comes to the surface and the amount of damage that a building sustains. So we need to be able to say, well, where are we likely to get that sort of condition? And where are we likely to get a condition where we only get a small amount of damage, a small amount of material that comes out from under the ground to the ground surface? So as a geotech engineer, that's really what I'm looking for, and we need to understand, well, where are these areas, where have they occurred in the past? Because we can clearly look to the past and say, is that a good indicator of future performance? And generally speaking, that's the case. But not every earthquake's the same. Not every seismic source is the same. So there are going to be differences between what we have experienced and potentially what could happen again. So we need to understand the ground conditions to be able to take account of those factors when we're looking at the type of repair that needs to occur or the type of rebuild that might be appropriate for a particular foundation. So, excuse me a moment, I might just lose the jacket, otherwise I might melt. So how do we do that? We've got a few techniques at hand that we can use. You've probably seen most of this already and aware of it. I'll just go over it briefly. The two principal methods that we can use to find out what's happening beneath the ground surface are what we call machine boreholes, where we physically drill a borehole and recover some core. We recover a soil sample so that we can look at it and poke it and prod it, rub it between our fingers, and if we're really keen, we might even taste it, although that's not usually recommended. And we can then also sample it and send it off to a lab for testing to understand the physical characteristics of that soil. Another key technique is a cone penetrometer test, or CPT, and you've probably seen a lot of those rigs around town in the last couple of years. There's EQC and a number of other organisations have done a heck of a lot of borehole drilling and CPTs around the city in the last sort of 2 to 2.5 years. Other techniques are more kind of hand-based, hand augers, what we call a scalar penetrometer, which is another instrument that we bang into the ground, count the blow counts. It tells us how strong or how weak the ground is. Also use geophysical techniques, where we put energy into the ground and then record how that energy comes back to receivers sitting on the surface. And of course, laboratory testing, where we can get a physical sample and we can understand what are the grain sizes in that physical sample and what does the material do, or how is it likely to perform under different kind of conditions. So just a bit of a view. On the left there you can see is a typical borehole rig. This will drill a machine borehole. You can get large ones and small ones depending on how big the area is that where you're going to put the machine and how deep you anticipate going. And we can see in the bottom right what that tends to give us back is a physical sample to actually be able to see exactly what the ground is and to be able to get some samples of that to test it if we need to. This is a view of a CPT rig. What it does is essentially it pushes a steel rod into the ground. On the end of that rod is a cone shaped, and then that cone, and in the area of the rod immediately behind the cone, we have a range of sensors that can tell us various things like how much push does it take to push the cone into the ground, what's the water pressure acting on the cone, and how much friction is there between the cone and the ground as it pushes in. And those are the key pieces of information that we need to understand the characteristics of the soil, and particularly in Christchurch, to help us predict where and to what extent could we get liquefaction in the future. So this is a pretty crucial type of test that we run to understand what's beneath the ground surface. Top left there is a view of a handheld DCP, or dynamic cone penetrometer, and I've also got a view there of some geophysical investigation techniques. As I was saying before, we impart some energy into the ground. Essentially it's as simple as a hammer striking a plate sitting on the ground, and then we have a whole series of listening devices, and they listen to the signal that comes back from that hammer blow, and with a nice but expensive black box, we run the responses through that, and then that can tell us or correlate what the ground conditions are. And it's a very good technique to get quite a bit of detail about the relative density, really, between one area of the ground or not. So, for example, on the bottom there, we can see an output from this geophysical technique. What you're looking at there is the top in the blue is where the ground surface is, and it's down about 20 metres where we've cut it off. You can see the dark red areas there are really dense, so that's gravel type material. The red is slightly less dense, and then the white is very, very loose, so it'd be loose sand. So this can tell us within quite a short space of distance between one point and another, how's the ground changing beneath the ground surface, which, if for argument's sake you want to put a building in, maybe you're downtown, you want to put a 6-storey building in, you might want to think a piled solution might be a good idea. Well, if you don't know what's underneath in the ground, you might put some piles down maybe 20 metres. You might think you're in that red area, and then 10 metres away, you're in a blue, which is significantly different in density. In which case, if you've piled to that depth, your building's not going to settle uniformly over time. It's going to tilt. So if you're doing that type of foundation, this can be a very good technique to tell you how consistent are the ground conditions beneath the ground surface, which is pretty important. Just to give you a bit of a flavour, I'm not sure how much soil there'll be left in Christchurch in a year's time, because it'll all either had a CPT or a borehole on it. There's literally been thousands and thousands of CPTs and boreholes across the city. It's been a major exercise, and it's still ongoing, but it gives you a bit of an idea of the amount of efforts that is required to really understand the ground conditions so we can get the foundation designs right. In terms of the geotech, that's the investigation methods. What do we get out of it? The key thing we get out of it is a model of the soil. What are the different soil layers? What are their strengths? What are the densities? Where's the groundwater table? And then we can use that to say, well, how consistent is that across the site? How do we take that account in the foundation design? Things like we do with that information is run a liquefaction analysis and a settlement analysis. We look at what's the bearing capacity for foundations. How much weight can we put on the soil? And that's obviously very important, in particular for a foundation rebuild situation, where there's a range of different methodologies that have been put forward to build, either rebuild the foundation or put a new house on. But you've got to marry those different methods to the actual ground conditions, which is what the geotech investigation will obviously tell us. Now, from the geotech, that's all below the ground. That's not really, you don't see that, but it's pretty important. Then it's what happens above ground. That's where, as a geotech engineer, we tend to hand over to the structural guys. They know a bit more about the structures and the performance of those structures than we do as a geotech engineer. So we work very closely with the structural guys to make sure that we match what the superstructure above ground requirements are and what the below ground requirements are to make the two work together. For the structural guys, the important things are in terms of a repair of a building and to some degree a rebuild of a foundation. How has the house performed already? What's the differential settlement? What's the settlement from one side of the house to the other? Is it different? In which case, has it tilted? That's the differential settlement. That's an important piece of information. As well as the amount of absolute settlement, which in some cases the whole ground surface has gone down. As far as a building's concerned, it's the differential settlement that matters more, because a building can easily ride along with the ground if it's settling as one, but if it's tilting and, for that matter, pulling apart with lateral spread, the building doesn't particularly like that kind of action. So it's what's happened to this building and how does that need to be taken into account to either repair or rebuild this particular site. Also looking at obviously the internal damage to a building. To what extent and what's the scope of the repairs that are required for the building? Does it mean we can just fix it, or do we actually have to start again and rebuild the entire building? All of those things the structural engineers have to have a look at and consider. Another important thing is the flood levels. In some areas of the city, the ground has dropped, means they're potentially more exposed to flooding in the future. So does that mean if we're rebuilding a footing and a foundation, do we have to raise the floor level a bit to keep it clear of potential floods in the future? All those things are part of the engineering elements that come into the structural side. So we're now able to marry the structural and the superstructure elements with what's happening below the ground to come up with a scheme to fix or rebuild the property. Just to give you a bit of an idea, some of these photos are of Housing New Zealand properties within both TC2 and TC3. So the type of damage that has occurred. You're probably familiar with these, but it gives us a chance to summarise those. We can see in the top right there the kind of the shaking failure that's occurred to brick cladding, and on the bottom left there a concrete ring beam in the corner has been shaken around and cracked from going through the brick course into the actual footing itself. The bottom right picture there is, I don't know if you might be familiar with Sorensen's Place in Richmond. There's, I think it's Swans Road, runs one way, and then Sorensen's Place comes off it at right angles. There's a few ground cracks have occurred there as you come down off Swans Road into Sorensen's, where the ground has literally kind of pulled apart. And in some cases, those cracks have got right underneath the buildings and contributed to the level of damage to those buildings. It's essentially broken the backs of some of those buildings. And that's a typical example of areas where the ground has moved sideways. It's not only settled vertically, but it's also moved sideways and pulled apart, which is an example of lateral spread. Other views of typical sort of damage in some of these buildings of Housing New Zealand's. This one on the top left is a two-storey brick-clad building. Again, we've got quite a lot of damage in the corners where the building has essentially twisted and the cladding has been popped off from the corner. We've got evidence in the bottom right there of cracks in the footings, and being lath and plaster, a few areas within the ceilings in the buildings have dropped off as well. Again, showing some of the shaking damage that's occurred to the building superstructure. The top right photo there shows where the bottom brick courses have moved laterally in relation to the two courses underneath it. So it's actually almost sheared across horizontally. So in that case, the cladding's going to have to come off and be put back on, but put back on obviously straight and true. This property here has been a little bit interesting. I don't know if you can make out, but in the top left, you can probably make out right in this is a 2-unit building. We're looking square on from the front. If you can look at the roof line, you'll probably see a bit of a dip in the middle. So clearly there's a bit of action going on underground there. And beneath those garages, there's now a cavity, and you can actually see, if you look carefully, where the front of the cars have risen up. There's actually a bulge underneath the asphalt, underneath predominantly the car on the right there. So there's been sand liquefaction underneath. The sand's wanted to come up to the surface. For whatever reason, it hasn't quite made it out through the asphalt, but it's bulged up the asphalt, and it's left a bit of a cavity underneath the garages, which have then sunk down. So that's probably, it'd be fairly nasty if you were experiencing that inside, and it's going to be quite a little tricky enterprise to fix that one. But this is one of the buildings in the foundation repair pilot program, which is, I'm looking forward to having a crack at fixing that one, see how we go. And speaking of cracks, another view of some cracking in a ring beam, a type B foundation with a concrete ring beam around the outside. And you can see in one area, in the top left photo, the house is L-shaped, and in the bit that kind of sticks out, the ground's actually sunk underneath it. And there's a close-up view of where the bottom window ledge is. You can see where it's separated and the bottom's dropped away. And that's quite typical of some of the Housing New Zealand houses that we're figuring out ways to fix that. So in terms of construction, I'm going to hand back over to Malcolm, and he's going to run through with you some of the types of techniques that are being trialled for fixing some of these foundations.
Thank you, Gordon. I noticed those last few slides are quite visual, and prior to that there was a couple of good slides which give you clarity as to the depth of involvement the geotechs really put into their analysis. of the ground and pass that on to the structural engineers who very seriously look at how the properties have responded. In the trial of the 20 properties, we met 3 times on each site with the geotechnical engineers and with the structural engineers, and they shared their information, and it was quite interesting watching the professionals tell us how the building had racked, moved, dropped, rolled, all sorts of expressions were coming, and pointing out where that damage could be seen. So in our trial so far, it's work in progress. The geotechs have shared their ground conditions with the structural engineers, and the structural engineers have put forward their recommendations how we can repair each of the properties that we have selected. We are trialling 5 different methods of lifting and re-levelling, and all the contractors have been given each site to price. So we are gathering several prices per property so we can analyse just how the costings on each method work. That the way forward will be to test each method on more than one property and to write up a document which trails that so that we can share with the rest of the Christchurch contractors and consultants how each process and method has responded. At the moment, we're in the middle of preparing documentation required by the council to apply for building consents to move forward. So we hope to very soon to be physically on site proceeding with some of those repairs. Just the slide at the moment may not be necessarily clear from where you're sitting, but an overview is showing 4 of those methods. The top left is a cross-section through the edge of a house showing you the foundation. So this is called a mechanical lift using concrete pads. So underneath the foundation, the contractors will dig a hole according to what the engineer says, about that square, about that deep, pour concrete. They'll leave a slot in that concrete to enable to put in a bottle jack which will take the load underneath that part of the house. So these pads are poured approximately 1.5 metres in sequence around the house, once again following the engineer's instructions. The lift is done very gradually at 1 millimetre at a time and consistently being reviewed with floor levels inside. The top right method is a metal screw jack that is drilled into the ground. Once it's in the ground, a metal bracket is bolted to the face of the foundation, and then a jacking system is put between the pile and the bracket, and once again the foundations are lifted. The bottom left picture shows ground injection. Holes are bored and a product is injected into the ground to fill voids and to stabilise the ground and lift the foundation. The one on the left is called an LMG injection. It is liquid, low mobility grout. As I said, it fills the spaces under the ground and allows the foundation to be lifted. On the right hand bottom corner is a similar process, but it is using a different product. It is using a resin. The resin is injected down underneath the ground and it expands, fills the voids and then lifts the foundation. So that's where we are at the moment with this pilot scheme, and we would like to keep the public and the consultants up to date as we proceed, and no doubt more information will be loaded onto our site. However, right now we're available for questions, so we'll hand it back over to Andrew.
I hope that was useful and there was answered some questions. Any questions from the floor? Oh, we've got some microphones, so just bring the microphone down. Thank you.
Can I talk? Yeah.
Sorry.
Does it work? I was just wondering about step cracks. You know, that the foundation has split and then there's some centimetres in between. the one slat is higher than the other.
Okay, Malcolm? You have to push the button on this.
So just to repeat the question, we've got a floor slab, and it has separated, and you're saying that the floor slab levels have changed. So your question is your question directed to a fix solution? I'm sorry, the lady's not there.
Yeah, I've just been told that the house will be repaired, so we're just wondering what are you going to do with it when there's a difference of several, in the foundation, two slabs of several centimeters. One is lower than the other one.
No.
There's, can you hear me? Oh, yeah. There's a couple of things that we need to consider there. There's ways of grouting that crack up. So we can use a chemical grout. It depends whether there's reinforcing within the slab, and depending on the width of the crack, whether that reinforcing may have been stretched beyond what it should have been. If it has, then that reinforcing would need to be replaced. So we can cut out an area of the slab either side of the crack. It might be a couple of 100 millimetres or 500 mil, depending, would be kind of cut out of the slab. Some new reinforcing would be laid down, and then the new concrete would be poured in to fill the gap and reinstate the integrity of that slab. If there's been horizontal movement. If there actually has been vertical movement across the crack, then there's a couple of things that can be done. Depending again how much that movement is. The top of the area that's sitting proud can be cut off or milled off, and over a certain distance it can be shaved off to make the slope of that repair as small as possible. So essentially you might not notice it, or again, depending on how much it is, it may be that a larger area has to be cut out and replaced. And also it would also depend on where the walls are, whether there are load-bearing walls coming across the crack or parallel to the crack, and that would also dictate or influence the type of repair strategy. It may well be also that there has to be a little bit of grout, in effect, pumped underneath the slab to lift one area of the slab to, again, bring them to the same level, to take away that stepped vertical step across the crack. So it's kind of horses for courses as to how big the crack is, where it is, how long it goes, and what else, whether there's load-bearing walls sitting adjacent to it or next to it or across it.
Yeah, the house is sunk on one side by 25 mils.
25?
Yeah.
Yep.
So.
Yeah, I mean, there's a couple of those as part of this foundation repair pilot program where we've got probably up to about say 70 mil, 75 mil, and we're actually using the grout injection to see if we can lift it that far. One of the things we don't really know for sure at the moment is what's the limit or what's the extent of lifting that grout injection technique can sustain. So we're having a bit of a go at trialling that to see how far up we can bring it.
Okay, thank you.
Hi, my question is what happens when the land under the area of your house that's sunk is extremely weak? Because you might be able to level it, but the land underneath is still not really going to support whatever you do on top, especially if it's still sinking now.
There's a few things we can do. There are a range of techniques that can be used to strengthen the ground, strengthen the soil, and they range from techniques that address the upper sort of, say, 2 metres of the ground, and effectively what's being done there is the land can be removed. We can mix it with a bit of cement, put it back in and compact it, and that gives us a very firm crust to then sit a house back on. If the ground is weaker, deeper, we can do some deeper what's called ground improvement techniques, where it's essentially a cement or a type of cement-based mix that gets injected into the ground at depth, and that can strengthen the soil down to, well, it depends how deep one's pocket is and how deep one needs to go as to how deep you do go, but from anywhere from, say, 8 metres to 20 metres if you needed to, but for a residential situation that'd be a bit unusual. Both of those things I've talked about, one the surface kind of treatment, the other the deep treatment, are essentially for foundation rebuilds or for new foundations, because you need a pretty good access to the site. And the nature of the ground and the strength of the ground should come in, or normally comes into the consideration of, is this a foundation repair or a rebuild?
And I think also to that, we've seen through the work that some of the contractors have actually said on a couple of sites that they don't think their product will be suitable for that particular reason. So they've been quite open about, you know, what can or can't be used on some of those sites.
Yeah, but in our situation, it's quite a small area of the property, so it's unlikely that you're going to get decent access to the foundations when it's a few metres, but it's definitely slumping in that area. So it doesn't sound like those solutions are going to work.
Well, I probably can't comment on individual situations, but again, it's envisaged certainly with Summer Housing New Zealand stock is to shift the house off the property. So lift it up, shift it off, fix the ground, put the house back on. And those techniques have been used elsewhere in the city, and for Housing New Zealand there's a fair number likely to be necessary for that. And that does depend, as you say, on what's the access like on and around the property. So there are a range of techniques we can use in the toolbox depending on the physical nature of what's there now and the ground conditions themselves.
Concrete ring foundations, if they're broken 27 times and stepped sideways by about an inch, are they had it?
I'd say so. Sounds like it.
They're unrepairable, aren't they?
Do you want to, Malcolm, do you want to answer that as far as what the guidelines actually?
Yeah, the guidelines actually refer to that quite, and you need to obviously work with your engineer, but if you walk around the perimeter of your home, the guidelines at DBH do say anything over 20 millimetres as a total addition. It means that perimeter foundation needs to be replaced. If you've only got major cracking in one corner, then that corner can be cut out and replaced. But when you've got it spread around the perimeter of your home, it's lost its structural integrity and should be replaced. However, discuss that with your structural engineer.
The guidelines we're referring to are the MBIE document that was published or put out. Well, it's been put out in various stages, but the latest incarnation was issued in December last year, which covers TC1, 2 and 3 foundation repairs and rebuilds and things. And that document is used a lot by practicing engineers and everyone dealing with foundation repairs and rebuilds to guide the decision-making process around, is this a repair, is it a rebuild, and if it's a rebuild, what type of technique might be appropriate for the house and the ground conditions. And that's available on the MBIE website.
Just a bit of background. My house is, the level's 220 out.
220 mil?
Yeah, and 100 widthways. And the extension's pulled away by 60 mil from the rest of the house. So the engineer says the guidelines are only guidelines. They don't actually have to adhere to those. So they're suggesting that it doesn't need to be rebuilt or the foundation have to be replaced. He's suggesting a movable foundation to push the extension back towards the house, and then in a future event it would pull away again and they just have to move it back.
Yep.
What do you think about that?
Sounds interesting.
That method has been used, part of the structural lifting processes where companies have poured these concrete pads underneath your house all the way around. They've lifted the house up to level, and then they've poured more concrete pads at the end of the house, and they've pushed the house horizontal. And they've brought your crack back to 1 millimetre. They've brought the fascia back in line to be re-riveted. So the technique is there, a lot of patience, and the technique is available. So it is a solution. Once you do lift at that at that height, we're dealing with voids underneath the slab. So there's another technique. They need to go inside your house, they need to drill holes, and they need to lift your slab up as well. So it's not a slab, it's piles. Fine. They can be packed.
A piled house is actually the most flexible, and certainly if my thinking is that the more flexible you can make your house foundation going forward, the better, because there's no way we're ever going to be able to design a house to not be damaged or to some extent by future earthquakes. We just have to try and limit the damage and then limit the repairs to something that is manageable, depending on the type of foundation that's then put in place. So, and you're right, it is just a guideline, and it very much is horses for courses, is that it's a very delicate mix in a way between the footing conditions, the subsoil conditions, the structural conditions, the type of house, age of house, type of foundation, all of that stuff. It all has to go into the mix to then come out with a workable solution. So there's no one size necessarily fits all. It is very much what is this particular situation that we're looking at. So it's not infeasible that solution would work in your case.
Are you doing any repairs in the flood management area? And if so, are you lifting the houses to now meet the new code, or are you using existing user rights?
We're doing 2 properties. However, we are not rebuilding the existing house into the same platform, so we're not testing the existing use rights. We are relocating an existing house from the red zone onto an FMA zone property. So we've had to work with the council's levels, and in both those properties we're having to raise the floor levels up to 1.2 high off the ground. That is another trial which we haven't talked about today, but it is an area where people are having to work with new rules, and I appreciate what you're saying about existing use rights.
Yeah, I mean, it's not necessarily a given that you have to raise the floor level to the 200-year flood level or whatever. It depends on not whether it's a rebuild or a repair, and if it's a repair, then existing use rights per se would probably indicate you don't have to raise the floor level. Clearly you want to be aware of it though.
Okay.
Yeah.
As far as...
if you want to talk to Gordon afterwards,
yeah,
he probably
feel
can't
free.
quite hear
Yep.
you at the moment, and they've moved the microphone to the back, so sorry about that.
As far as the data that you're collecting from the trialling of the 20 houses, first question is there an expected time frame or a date that information will be released? And also, for houses that have their repair strategy or scope of works in with the council for consent at the moment, if that gets approved by council before this data and we find that there's a difference of opinion there, what happens under those circumstances, and what us as homeowners would be the methods that we'd then go about then and checking to make sure that actually fits the new data?
The process that we're working through at the moment is, as you say, today's rules. The trials are today's methods, and therefore the whole purpose of this trial is to provide current information to help you out there in the public know what's available for good solutions. The council, after this trial, and it's going to be a good 2 months for us to physically do the work, and then after that to release documentation. But the information we learn will be shared between MBIE, brands, City Council. They will then sit together and see if any of their documentation needs to be slightly adjusted. But that we won't know that for another 2.5 months.
Yep, that's fine.
Yeah, hi. Just wondering about the repair strategies. Would any of them be considered as new as far as an insurance policy goes, or would it be just a fix?
Your wording of as new is a policy wording. With our floor levels, that's what you're referring to. You got your foundation damage, to be repaired. You've got your foundation to be relevelled, which also reflects right through your floor plane. So as new is bringing that floor back to a workable floor level. It's an area of discussion. I know that the guidelines are out there as well. In our trial, we will be managing this and trying to bring those floor levels back to as near new as possible. Other than that, we can't comment on how wise that is on the structure. A lot of these houses have been sitting bent for 18 months. We don't know how easily they're going to come back to straighten. They've got memory in them. We're not too sure how well they're going to respond. So, a bit early to really qualify how we're going to achieve all that.
So it won't be considered as new, basically. That's what I'm asking.
Sorry, I can't hear you.
So would it be considered as new as a fix? I know the EQC Act says they will repair the house substantially as new condition, whereas this is a epoxy grout that's not as new. How would that be considered? I don't quite understand.
That's a structural question.
Well, the epoxy grouting up a crack in a ring beam is essentially putting back the strength and integrity of the original ring beam. So I guess in my opinion it would be putting it back to at least what it was before. I haven't had any personal experience using the epoxy grout, but a colleague of mine had quite a few cracks in his house. He had a concrete slab floor and quite a lot of concrete work in the walls as well. I shouldn't laugh, it's not funny, but he had the cracks in the floor epoxy grouted up following, I think it must have been following the February event, quite quickly after the February event. And then in the June aftershock, his floor cracked again, but it didn't crack where the grout was, it cracked elsewhere. So it clearly put back renewed the strength in the concrete. So, you know, I don't personally have any worries with the epoxy grout being a good product to use to reinstate.
So how long would epoxy grout last for? What's the lifespan? Has it been tested for 50 years, which was be as new, I suppose, as far as the foundation goes?
It's the same design life as the concrete.
Ladies and gentlemen, thank you for attending the Zero Rebuild and Recovery Expo. Just to let you know that we will be closing in 10 minutes at 4 o'clock. Thank you.
Which means we can take questions for about another 5, I expect. Is there any further questions? Quite a few. The microphone's just moving over at the moment. Yeah, 2 more questions and we'll have to wrap it up for the day.
If these repairs that are deemed practical at present fail, who's responsible then? Down the track.
Yeah, good question. As that's not really been tested yet, it's hard to say. I think, to be fair, the engineers, the council, the geotech guys, and the guys who actually do the work are giving warranties as much as they possibly can on their work for what it's for what they expect is the lifespan of that.
Can't hear.
Yes, sorry. On a case-by-case basis, it's really hard to say. I don't know. Not knowing exactly what they did at your property or...
Well, it's not done yet. But
not done yet.
When I asked how long is it guaranteed for, it was for 12 months.
Okay.
Well, that's not much, is it?
Hard for me to comment on that as well. But that's where you know, if something went wrong again, that's why we still have insurance as well. If that product failed in the future, that's why we all still have insurance. One last question. One right down here.
Yeah, Smith's Cranes brought in this new lifting device. Are you lifting any of your houses with that? Put foundations under them?
With these particular trials, no, we haven't. The methodology that Smiths have brought in, we haven't looked in detail as yet. So this is more about trying to fix it rather than lifting. We are looking at lifting some houses, but we haven't done a huge amount of work at looking at all those different methodologies. And I think that's only been in place for about 2 months. From what I understand, it would be suitable for some quite medium to high-end property as far as the value is concerned. For our type of property, it may not be the most perfect way to try and lift a house. There's other methodologies that might be more suitable. Excellent. Well, thank you very much for attending. Lots of great questions, and we're not doing this again tomorrow, so thank you very much.